All right, today we're going to be talking about Chapter 12, Lesson 7. This is all about volume of pyramids, cones, and spheres. So when it comes to the volume of a pyramid, the volume of a pyramid is going to be very similar to when we did the volume of a cylinder. It's going to be related to the area of the base and the height. The only difference is it's going to be 1/3 the area of the base times the height. Now, depending on what the base is, you would have to do either, in this case, this is a rectangle, so this would be length and width. If it was a triangle, it would be length times width divided by 2 because that was a triangle. If it was some other shape, it might even give you the area of the base. Let's go ahead and look at this example here. Example 1, find the volume of the pyramid. So we'd have volume equals 1/3 area of the base times the height. The base in this case is a rectangle. In fact, it's a square. But it'd be 15 times 15, which happens to be 225 units would be inches squared on the base. Start substituting in. So h in this case is this height, which is 12 inches. So I have 225 inches squared and 12 inches. If I go ahead and multiply those two numbers together, 225 and 12, I get 2,700 inches cubed now. And then multiply that by 1/3, so the volume in this case would be 900 cubic inches. Now, the next shape we're going to talk about is the cone. And in fact, a cone is very, very similar to a pyramid, where we still have 1/3 times the area of the base and the height. The only difference is the base in this case is a circle, so we'd have pi r squared as the area of the base. So the overall formula for the volume of a cone would be 1/3 pi r squared h. And we can make a formula like this because for a cone, the base is always a circle. So example 2, find the volume of the cone and round to the nearest tenth. So again, I have 1/3 pi r squared h. The radius in this case is, again, from the center to the edge, so that'd be 5.5 meters. And the height is from the tip of the cone down to the base, and that is going to be 8 meters. So I want to substitute these numbers in, so I have pi, 5.5 meters squared, and then I have 8 meters. Start to simplify, so 5.5 squared is 30.25. Multiply 30.25 and 8. I get 242 meters cubed now. And if I simplify all of this, 1/3 times pi times 242, I get the volume is about, and because we're rounding to the nearest tenth, we have to put the about symbol. It's really 253.293 repeating, so I'm going to use 253.3 meters cubed. And that's an about answer because it's rounded. Last thing we're going to be talking about is the volume of a sphere. So the volume of a sphere is very different. Volume of a sphere is 4/3 pi r cubed, where again the r is the radius. So let's go ahead and do an example off of that. So find the volume of the sphere and round to the nearest tenth. So again, volume is 4/3 pi r cubed. R in this case is the radius, which is 5 feet. Start substituting values in 4/3 and pi. R is 5, so we're going to use 5 feet cubed. If I simplify now, 5 raised to the 3rd power, or 5 cubed, is going to be 125. And if I simplify the rest of this answer, I get volume, again, is about, because we're rounding, but 523.3 cubic feet. Last thing. Example 4, a spherical beach ball has a diameter of 12 inches. So because it says spherical, that means we're going to be looking at the volume of a sphere. Has a diameter of 12 inches. The radius is half of that, so the radius would be 6 inches. So it says find the volume of the beach ball, and then find out how long it would take to deflate the ball if it is leaking at a rate of 1.5 cubic inches per minute. So, find out the volume first. 4/3 pi, 6 inches cubed. So 6 cubed, or 6 times 6 times 6, is 216. And if I simplify all of this, so the volume, again, we're going to make an about number, is going to be 904.3 cubic inches. Again, that's an about number. The next thing we need to figure out is how long it's going to take to deflate. So, we want to do this 904.3 cubic inches. We want to get it to minutes, so we're going to divide by 1.5 cubic inches per minute. And if we do 904.3 divided by 1.5, we get 602.9 minutes. And of course, because this is a word problem, we should have a word answer. So it would say the ball would take 602.9 minutes to deflate. All right, that is the end of lesson 7. If you have any questions, please let me know.